right, let's look at your Chapter 6 material for your exam. This is our inequalities. So remember we said that you're going to solve an inequality exactly as if this was an equal sign, unless you multiply or divide by a negative, and in that case you reverse this inequality sign. So if I treated this just as if this was an equal sign, the first thing I would do is get all of my x's on the left-hand side. So I would subtract 3x from both sides. So now I've got 2x. And to get x by itself, I'd want to get rid of this minus 12. So to undo subtracting 12, I add 12 to both sides. So now I've got 6 plus 12 is 18. And to get x by itself, to undo multiplying by 2, I would divide by 2. So divide both sides by 2. And I've got x is greater than or equal to 9. All right, so greater than or equal to, if it has an equal to with it, we're going to use a closed dot. So greater than equal to or less than equal to. If it doesn't have an equal to with it, then I'm going to use an open dot. All right, so if you think about the numbers that are greater than 9, that would be like 10, 11, 12, 13. Those are all values over here to the right, so we're going to shade to the right. We also have a little shortcut that if x is on the left-hand side, that you can make an arrowhead out of this little greater than sign, and you can see that arrow would also tell me to shade to the right. But that's only when the x is on the left-hand side. All right, let's look at number 2. So number 2, same idea. We're going to solve this just as if this was an equal sign right here. I want to get all my x's on the left, so I'm going to subtract 6x from both sides. So now I have a negative 2x, and I want to get rid of adding 8, so the inverse of that would be subtracting 8 from both sides. So now I have negative 2x is less than or equal to negative 6. To get rid of multiplying by negative 2, I would divide by negative 2. And remember, that's the one thing that we do differently with an inequality. If you multiply or divide by a negative, you have to reverse that inequality sign. Negative 6 divided by negative 2 gave us positive 3, so our answer would be x is greater than negative 3. Now, because this doesn't have an equal to with it, we're going to use an open dot. So greater than, less than, we use an open dot. And the numbers that are greater than 3 would be like 4, 5, 6. Those are numbers to the right. And again, you can use that shortcut since x is on the left. You can make a little arrowhead out of this, and it'll show you that you're supposed to shade that direction as well. All right, number 3 is a combined inequality. Now, for a combined inequality, that's literally just 2 problems combined into one. So you can see I can break, this is an and statement. This is 3 is less than or equal to 2x plus 5, and at the same time, 2x plus 5 is less than 11. So I can break that into 2 separate pieces so that I have 2 smaller inequalities to work with. So let's work with the 3 is less than or equal to 2x plus 5 first. So let's subtract 5 from both sides. That would give me negative 2 is less than or equal to 2x. And then to get rid of multiplying by 2, I'll divide by 2, and so I'll end up with negative 1 is less than or equal to x. Now, notice I didn't reverse the inequality sign. I divided by 2 and got a negative number, but I didn't divide by a negative 2. So I have to multiply or divide by a negative in order to reverse that sign. All right, so similarly over here, let's go through and subtract 5 from both sides. So that would give us 2x is less than 6. To get rid of multiplying by 2, we'll divide both sides by 2, and x is less than 3. So my answer is negative 1 is less than or equal to x, and at the same time, x is less than 3. So we can combine that into one inequality, negative 1 is less than or equal to x, and less than 3. So to graph that, we said that a and statement is going to be an intersection. If I go through and I graph negative 1 is less than or equal to x, and I graph x is less than 3, it is just where they overlap that will be my solution. And so you'll notice that less than equal to is a closed dot, less than is an open dot, and we just want the values that are in between negative 1 and positive 3. So these are the values that are in between negative 1 and positive 3. These would be the only values that are larger than negative 1 and at the same time smaller than positive 3. All right, the next inequality that's combined is an OR statement. All right, so when we have an OR, We have two separate inequalities again. Let's solve those first. So to begin with, to get rid of adding 1, I'm going to subtract 1 from both sides. So 11 minus 1 gives me 10. And then I'm going to divide both sides by 5, so that would be x is less than 2. All right, then similarly over here, I'm trying to get rid of adding 1, so we'll subtract 1 on both sides. So that would be negative 3x is less than or equal to negative 11 minus 1 is negative 12. And then to get rid of multiplying by negative 3, we're going to divide by negative 3. And here I did multiply or divide by a negative, so I do have to reverse that inequality sign. So negative 12 divided by negative 3 would give me positive 4. So I've got x is less than 2 or x is greater than or equal to 4. Now, when it's an or statement, it can be one or the other. It does not have to be both. I'm going to keep both of these pieces on my graph. So I'm going to graph x is less than 2, so open dot on 2, shading off to the left for the values less than that. And then x is greater than or equal to, since it's got the equal to, that's going to be a closed dot on 4, and shading off to the values greater than 4, like 5, 6, 7. And again, we can use that little shortcut here where we can make an arrowhead out of that, and it tells me to shade this direction. And because our x is on the left, we can also do the same thing here, make an arrowhead, and it tells me to shade in that direction. All right, then number 5 is an absolute value equality. So we said that for an absolute value equality, we would take what was inside the absolute value and set it equal to a positive and a negative of what's on the other side. So we're going to take x plus 2 and set it equal to a positive and a negative 3. So here it's set equal to a positive 3, and here it's set equal to a negative 3. So I'm going to solve those two equations. To get x by itself, let's subtract 2 from both sides, and I'll get x equals 1. And then over here, subtract 2 from both sides, and I'll get x equals negative 5. So those would be my two solutions, positive 1 and negative 5. Now, that's an absolute value equality when I have an equal sign. Notice that this next one is an absolute value, but it's an inequality. So that's when I have like a greater than or a less sign, all right, less than. So we said that if it was a greater than, that was going to be a disjunction or an or statement. And the easy way to remember that was that you could take that symbol and make a D out of it. D for disjunction, disjoin, break it apart, or. And then we said that if it was less than, that's the one that looks like a C. That's a conjunction. That's an and statement. All right, so we said to do our absolute value inequalities, we were going to copy exactly what we had. So 2x plus 5 is greater than or equal to 3. Copy the same sign on the other side. Copy the opposite number. And we already said this was a disjunction, so we know we're going to have to break it apart into two separate pieces. All right, so if we solve here, I'm going to subtract 5 from both sides. So that would give me negative 8 is greater than or equal to 2x. And to get x by itself, let's divide both sides by 2. And so I've got negative 4 is greater than or equal to x. Now, if you like your x on the left-hand side, that's fine. You can move your x over to the left and your negative 4 over to the right. If these two swap places, then our sign is going to have to be reversed. And you can see that. You can see the little end is toward the x and the big end is towards the negative 4. Same thing here, little end towards the x, big end towards the negative 4. All right, then over here, same thing. Let's subtract 5 from both sides. And then divide both sides by 2, and we'll get x is greater than or equal to negative 1. So you can see this is that same type of combined inequality we were doing a second ago, where we said we would keep both pieces of the graph. And so x is less than or equal to negative 4. We're going to have a closed dot there, and here are all the values less than. X is greater than or equal to negative 1, closed dot there. Here are all the values greater than. All right, for the next one, we said that this one would be a conjunction, an and statement. So again, let's copy exactly what we've got, copy the same sign, copy the opposite number, and this one we're going to leave it all together as an and. When it was an or, we had to break it into the two separate pieces on number 6. So for this guy, we can leave it all together. So to get C by itself, we need to get rid of subtracting 3. So let's use adding 3. So we'll add 3, add 3, add 3. So negative 7 plus 3 gave us negative 4. Here the 3's canceled out, and 7 plus 3 gave us 10. So negative 4 is less than C, and C is less than 10. So there is our combination. And so open dot on negative 4, open dot on 10, and all of the values in between them. All right, then when we want to graph an inequality with two variables, so the difference is you'll notice that this one has an x and a y, where all the other problems we were doing only had an x in them. So the only way to write the answer for this is to graph it. All right, so we're going to start off, we said, by treating this just as if this was an equal sign. So if I were graphing 2x minus y equals 4, there are lots of different ways you can graph a line, so it's really whatever you prefer. One of the ways that we said we could do that is we could make an XY chart and just plot any values that you want to. Easiest values to plot are usually the x-intercept and the y-intercept, so put 0 in for x and 0 in for y to find those. So if I put 0 in for x right here, that'd be 2 times 0, so that piece would drop out, and I would be left with negative y equals 4. Equals, remember we're treating this just as if it said equal to. So negative y equals 4, that would give me y equals negative 4. And then let's put 0 in for y. So if we put 0 in for this y right here, that would leave us with 2x equals 4. So if 2x equals 4, divide both sides by 2, and x would equal 2. So that would be the point 2, 0, and the point 0, negative 4. And then we can draw our line. Now, remember we said that if it's just less than or greater than, we're going to use a dotted line. If it has an equal to with it, we'll use a solid line. So for this one, it was just less than, so that's why we've got our dotted line here. Now that's one way you can graph a line. You might also prefer to take your line and put it in slope-intercept form so that you can graph by using rise over run. So if you wanted to do that, we would start off with 2x minus y is equal to 4. Remember, we're graphing it just as if it said equal to. I would have to get that into slope-intercept form. So I would subtract 2x from both sides, and then I would have to divide both sides by negative 1 to get y by itself. So negative 2 divided by negative 1 gives me positive 2, and positive 4 divided by negative 1 gives me negative 4. So my slope would be positive 2, and my y-intercept would be negative 4. So I would start at the y-intercept, so start at negative 4, and then I would count my slope of 2 over 1, so that would be a rise of 2 and a run of 1. Rise of 2, run of 1. Rise of 2, run of 1. So back in chapter 5, when we were graphing our lines, those were the two different ways that we did it. Doesn't matter which way you do it. You can either find your x and y-intercept and plot those points, or you can do your plotting your y-intercept and doing your rise over run. You don't have to do it both ways. All right, so now that I've got my line, now I just have to figure out, am I going to shade on the left-hand side or I'm going to shade on the right-hand side? And the way that I do that is with a test point. So I'm going to take the point that is a point that is not on the line. I like using 0, 0 if it's not on the line. And I'm going to plug that into my original problem. So that would be 2 times 0 minus 0 is less than 4. 2 times 0 minus 0 is less than 4. And that would give me 0 is less than 4. So since that's a true statement, since that point worked, that means every point over here on this side is going to work. And so I'm going to shade on this side. And the graph is the only way to write my answer. All right, so then for number 9, same idea. So we're going to treat this as if it said equal to. So you could either look at it and say, okay, my slope is negative 3 and my y-intercept is 3. And so I would start at a y-intercept of 3, and I would rise a negative 3, run a positive 1, rise a negative 3, run a positive 1, and that would give me my line. Or you could put 0 in for x, so this piece would drop out, and that would be y equals 3. And you could put 0 in for y, and that would give me negative 3x plus 3 equals 0. Subtract the 3 from both sides, and we would have negative 3x is equal to negative 3, so x is equal to 1. So either way you want to go, you can see I would have 0, 3, and 1, 0. Again, I would have that same line. Now for this one, because it had the equal to with it, we're going to use a solid line. And then to figure out which side to shade, we're going to use a test point. 0, 0 was not on my line, so I can use it as a test point. So I'm going to go back to the original equation, and I'm going to put 0 in for y and 0 in for x. So I got 0 is greater than or equal to negative 3 times 0 plus 3. That is not a true statement. That point does not work, so I shade the opposite